Okay, so last section we're going to look at is 2.1. You might get to part of 2.2, but definitely not finishing it. And this whole chapter is on polynomial functions. So we'll talk about what makes something a polynomial, and then some different characteristics of polynomials, like how you can tell what they're going to look like, how many turns the graph can have, things like that, just by looking at it. So let's just graph that and see what happens. And what I want to look for is how many times it crosses the x-axis. All right, so let's go to y equals. If you have anything in there, you can just clear it. And we've got 2x cubed minus 3x squared minus 3x plus 2. I'm going to start with the standard window. If it goes off the screen up and down, not a huge deal, but I do want to try to make sure I can see all the places it crosses the x-axis. Actually, that's perfect. If they asked for a complete graph, that's perfect. So let's just bring that over here. Make it a little smaller. Okay, so looking at it, how many times does that graph cross the x-axis? Rob? How many? 3, yeah, crosses 3 times. Now, if you look at the highest exponent, it's a 3. The graph crosses 3 times. That's not just a coincidence, that's kind of a pattern. This number doesn't guarantee you the graph will cross 3 times, but it does guarantee you it can't cross more than that. Okay? Bless you. So if I, if I were to graph something like, let's just graph x cubed. So highest exponent in that one is a 3. But look how this one looks. Similar, right? You kind of, on the left side it's going down, on the right side it's going up, but it only crosses the x-axis once. It's not doing the turns in the middle like the other one. So the exponent is just an upper limit on how many times it can cross the x-axis. Okay, what's the y-coordinate of any point if it's right on the x-axis? What's the y value? Yeah? Yeah, it's always 0. So the y value, or the y part of any coordinate, if it's right on the x-axis, is always 0. So I'm going to show that what I have right there is the same thing as what I have right up above. 2x cubed minus 3x squared minus 3x plus 2. And eventually, you're going to be able to take, well, eventually I'm going to teach you how to take that and turn it into that. Right? To reverse it, that's a lot easier. All I have to do is FOIL that out and see if I get the same thing back. Okay, so let's FOIL it and see what we get. The original one, 2x cubed minus 3x squared minus 3x plus 2. So let's see if we get that. All right, so if we FOIL it out, the first one we get 2x squared minus x plus 2x. What's minus x plus 2x? Okay. So we did 2x squared minus x plus 2x. I'm sure. Chris, can you help him out?
Which one was it?
So we're doing minus x plus 2x. So we're just foiling that part out.
There would just be one, or just x?
Just x, yep. And then 1 times negative 1, negative 1. All right, so we FOIL the first part, now we're going to do it all again. This time it's a little bit more involved because now we have a trinomial times a binomial. Gabe, can you start off whaling out? We'll start with the x to each term.
So 2x cubed plus 2x or x squared minus 1x.
Yep. So we did the first term in the binomial to everything. Now we're going to distribute the -2 to everything. So Kathleen, can you distribute out the -2 for me?
Minus 4x squared
Mm-hmm.
plus 2x.
Minus 2x plus 2. Okay, so let's combine like terms and see if we get what we just had up above. So we have 2x cubed. So we did that one. X squared minus 4x squared is minus 3x squared. Negative x, negative 2x. So we did those. And then a plus 2. Let's go back up and see if 2x cubed minus 3x squared minus 3x plus 2 is what we had. Be easier if I can get them on the screen. But yep, 2x cubed minus 3x squared minus 3x plus 2. So what's in parentheses right there is exactly the same thing. Okay. Why would you want to write it in parentheses like that, though? Does anyone know? Justin, have any thought why you might, or do you know what's it called when you write something as sets of parentheses like that?
I don't know.
Trying to remember what that's called? You do it with quadratics in Algebra 1 quite a bit. Oh, Rachel? Factoring, right? Factoring. Right? When you write something like with sets of parentheses, you're factoring it. So why do you factor quadratic equations? What's the point of factoring them? Yeah.
I know what x is.
Yeah, you're trying to solve for something, right? So if you can't factor it, use quadratic formula. Well, let's figure out where our graph crosses the x-axis, and then I'm going to come back to the factored form of that equation and try to make a connection. So I'm just going to get rid of what's in red because I don't need that. Okay, so just looking at the graph in blue, I'm going to calculate where it crosses the y-axis. I think we've done this, but if not, we'll go through it. Second, calc. And then I want to calculate a 0. A 0 is where it crosses the x-axis. So 2. Pick a point somewhere to the left of your 0 and hit enter. Pick a point somewhere to the right, hit enter, and then do a guess. And you have to do this 3 separate times to get each one of them. But the first one is at -1. Without going through it 3 separate times, I can tell you the next one is going to be at 1/2, and the other one is going to be at 2. If you do second calc 0 3 times, those are the numbers that you'll get. Well, let's go back to the factored form of this equation. So x plus 1, 2x minus 1, and x minus 2. Okay, we just use the calculator to figure that out. Where do those equal 0? Okay. Well, I use the calculator for the first one, and the other 2 I told you you could try it, and you will get that. But looking at this, how can you multiply 3 things together and get 0? What has to happen if you multiply 3 things together and get 0? Yeah.
Everything cancels.
How though? What would have to be part of the calculation if you multiply 3 things and get a 0? 0 would have to be in there somewhere. Well, look what happens if you say, let's pretend that the first one was 0. Well, if the first one is 0, look what you get. -1. If the second one was 0, you would get 1/2. And if the third factor was 0, you would get 2. So that's the reason why you would want to factor an equation. It makes it very easy to find the 3 numbers you could, or however many numbers there are, to plug in and get 0. Not very easy to do that if it's written like this, right? So eventually we're going to learn how to factor something like that, okay, but not today. Yep.
Wouldn't the third one be -2?
What did I put?
Because it's 0 and -2.
No, you have to plug in 2 because 2 minus 2 is 0. If you plug in -2, it would give you -4 for that factor.
Okay.
Does that make sense? So you plug in 2, you get 0 here. If you plug in a half, 2 times a half is 1, minus 1 is 0. And if you plug in -1 plus 1, you get 0. So those are the three zeros. They're also called the 3 roots. So if you hear the word root, or you hear the word 0, it means the same thing. In fact, in older calculators, if you go to second calc, this one calls it a 0, but actually, I think it's even a little older than this one. I go to this one. Try again. If I go second calc, this one calls it a root. So you might see the word root depending on if you have a different calculator. But find a root, find a 0, find where it crosses the x-axis. All means the same thing. That's what I just said. So if you can find a number that's a solution to the equation when you set it equal to 0, you have just found the coordinate for an x-intercept. That value that you find is called the root of the equation. It's also called the 0 of the equation. If you consider complex numbers, then the exponent, the highest exponent in any polynomial, always tells you how many answers there are. Always. What gets a little tricky is when you look at something like this, and you say, well, if there's always 3 answers, and each answer is where it crosses the x-axis, that doesn't cross 3 times. That only crosses once. You're right. There's only one real answer, and there are 2 imaginary answers. So there are still 3 answers to x cubed. It's just sometimes they're real, sometimes they're imaginary. Depends on the problem. For now, we're going to focus on answers that are real. Okay, just real. So, for simplest kind of equation is a linear equation. And how many times, besides a horizontal line, how many times can a line cross the x-axis? Yeah, just once. If you had a horizontal line, it might not cross at all. That's different. But a line that's not horizontal, that can be written in the form ax plus b, like mx plus b, same thing, will only cross once, and here's the solution. It's negative b over a. It's basically just taking the constant, moving it to the other side, and then dividing by the number in front of x. And so finding the root of a linear equation, that's not that bad. Because there's only one answer, it's pretty straightforward. Alright, so let's look at that one. 2x plus 3 equals 0. Kaylee, where would that equation, if you drew it, where would it cross the x-axis?
3.
Alright, let's check it. If you plug in 3 for x, what's 2 times 3?
Oh, 6.
6 plus 3 is 9. No, that didn't give us 0.
So do you want to plug in something that will make the 2x plus 3 0?
Yeah, I have to find something to plug in for x that makes this equation true? Not sure. Yeah, Nate?
Is it negative 1.5?
Yeah, can you say, how could you get that if somebody doesn't quite understand where you got that from?
Negative 1.5 plus 3 equals 0. I mean, negative 1.5 times 2 plus 3 equals 0.
Yes, I agree with you, that's right, but pretend that somebody couldn't figure out, they couldn't guess negative 1.5.
You subtract 3.
Yep.
And divide that by 2.
Subtract 3 from each side, divide by 2, x equals negative 1.5 or negative 3/2. Same thing. Yep. Do you have a question?
No.
No? Okay. And that's it. So this particular graph would have an x-intercept of negative 3 over 2. And it has a y-intercept of 3. So if we wanted to draw it, that's enough information. If you know the two intercepts, just mark each point and draw a line through them. Okay, so let's go to the next step. So how many times can a graph like that cross the x-axis? It's not guaranteed it'll cross this many times, but it could cross up to this many times. Allison? 2. Okay, this is a parabola. So you could cross twice. Well, I said to you that there's always two solutions. And if the solutions are where it crosses the x-axis, then, well, what's going on with something like that? Well, the solutions are imaginary. All right? So there's always two answers to this problem. It's just they might be imaginary, or they could be real. Okay, so we talked about how the discriminant, that's the thing under the square root, the b squared minus 4ac, how that can tell you how many roots you have. Remember, if the discriminant came out negative, you have no solutions, and we're just talking real numbers. You have no real solutions. If the discriminant equals 0, you have one solution, and if the discriminant is positive, greater than 0, you have two solutions. Okay, we wrote all that down. It was very end of, it wasn't yesterday's lesson, maybe the day before. Okay, so it's all broken down into cases, whether this comes out less than 0, equal to 0, more than 0. No solution, one solution, two solution, in the order I just sent them. Okay. What b squared minus 4ac doesn't do for you is it doesn't tell you what the solutions are. It just tells you how many there are. If you actually want to find what they are, then you either need to factor, graph and use the calculator to figure it out, complete the square, quadratic formula, however you want to solve it. But that is a quick way to just figure out how many real solutions there are. Okay, and if I don't say the word real before solutions today, just assume I'm talking about real numbers. We're not doing complex. All right, so this one just says to solve approximately. Okay. If it said solve exactly, I'd have to use quadratic formula. But to solve approximately, I can do it on the calculator. All right, so since we're dealing with roots, anytime you want to find a root, what do you have to get the equation equal to? What number? Trying to find an x value that makes y 0. So let's get 0 in the equation. So just move everything to one side. It doesn't matter what side. I like to keep the squared term positive, so I'll do it that way. So I'll move everything else to the left. So 2x squared plus 2x minus 1 equals 0. Okay, and if it said exact answer, I'd now be plugging into quadratic formula. Or if I could factor it, I might try that first. Okay. But it just says to solve approximately, so let's practice using the calculator. So I'll type it in, and then I'm going to ask somebody, what do I do from that? So 2x squared plus 2x minus 1. Okay. How about, Jacob, what do I want to do now that I typed it in?
The graph.
Yeah, let's just see graph. Let's see what's going on. Maybe it's off the screen. If it crosses off the screen, that's a problem. I need to change my window. Well, we're lucky. It's perfect. So we can see exactly where it is. If you want to zoom in a little bit, that's up to you. Zoom to. Hit enter, and then put the plus sign close to where you want to zoom in. There was no reason to do that, but just so you guys can see it a little easier. All right, so there's definitely two real solutions to the problem. And Joe, how do I find them? Remember, we have to press on the calculator?
No.
Not sure? You want to help him out? What do we press? Yeah, Katie?
Second calc. And
Yep.
2 for 0.
All right, and can you guide me from there what I have to do?
You want to stay on the left of one side.
All right, so I'm going to have to do this process twice. I'm going to go to the left of one of them, okay?
And then enter.
Yep. Hit enter.
And then go on the right.
Yep, so you're basically telling the calculator, okay, look between these two lines. And then the guess, well, it's not really important because it only crosses once. So one of my answers is negative 1.37. And now we need to do it again for the other root. Does anybody have what the other one comes out to? Yeah? Awesome. 0.366, so I'm going to round that to 0.37. Directions didn't say specifically what to round to, but in general, if it doesn't, for most things, 2 decimal places is good. Good. Any questions on that? So these two answers, if you're doing quadratic formula, would have come from the plus or minus square root. One of them would be the plus answer, the other one would be the minus answer. All right, so it's a quadratic. Okay, so this part, I just want you to watch this. I don't want you to actually do anything here. Older calculators, in fact, older than the one I can do on the screen, they didn't have second calc. Okay, so you couldn't calculate a 0. The only way to do it was to put, let's put even more tick marks on the screen. So I'm going to put a tick mark every half a unit, just to kind of increase my accuracy. So looking at that, what I could tell you is, okay, it looks like there's an answer between 0, remember that's 0.5, and that's 1. So there's an answer somewhere between 0 and 0.5. And then what I would have to do is, all right, let's put some more tick marks. Like let's put one every 10th. So now you got to put more tick marks, but now you can't really see. So now you've got to zoom in and then say, okay, you know, if I zoom in, looks like there's an answer between 0.3 and 0.4. I can kind of see it, but I'd probably have to zoom in to make sure. And then I'd have to put even more tick marks and then zoom in again till I finally get the answer as accurate as I want. Okay, kind of time consuming. Now we don't have to. You just do second calc, 0. Much easier. All right. So if your book mentions trying to do something like that, don't worry about it. All we're doing is second calc 0. And when they say with like a maximum error of 0.01 or a maximum error of 0.001, that just means round to that many places. So maximum error of 0.01, that's what we did right here. We rounded to the nearest hundredth. Okay. So don't worry if you see anything like that. Just do it the way I showed you. That's what we just did. So use the 0 feature. Okay, let's try this one. So it's x cubed plus 2x equals 1. Okay, in order to use the 0 feature, Haley, what's the first thing I have to do to that equation before I can type it in?
You have to put everything on one side.
Yep, and how could I do that here?
Do -1 on each side.
Yeah, that's the easiest way, just -1. you're good. So the highest exponent is a 3. Does that guarantee it'll cross 3 times?
No.
You think, no. It could cross up to 3 times. Okay? Could cross 2 times. Could look like this. So it kind of crosses it, touches it, and goes back up. Could cross 3 times. Or it could cross just 1 time. But it will guarantee it'll cross 1 time. Because any polynomial with an odd number right there goes up forever and down forever. Well, if you go up forever and down forever, bless you, you got to go through 0 at some point. Okay, so you'll always have to cross at least once. Unlike a parabola, parabolas don't have to cross at least once because they don't go up and down forever. Okay, so x cubed plus 2x minus 1. So x cubed plus 2x minus 1. Okay, hit graph. I've got a lot of extra tick marks on there. Doesn't really matter. And I'm zoomed in enough. It's a little hard to see the curvature, but it is a cubic. But there's only one solution. If you zoom out a little bit, you could see that it never curves, never comes back down and back up on the axis. So does anybody have what that one solution comes out to? Yep, Caleb?
0.45.
So x is about 0.45. Now, this one's set to solve approximately. You don't really have any choice. I don't think anybody in here knows the cubic formula, like the quadratic formula. So when we're dealing with cubics, a lot of times we're stuck with getting an approximate answer. Are there ways to get exact answers? Oh yeah, but not really something we do. Quadratics, I would expect exact answers. You should be able to do it, but nothing higher than a quadratic. Okay, so some of the polynomials we've been looking at, those have been what we call third-degree polynomials. So they have the form ax cubed plus bx squared plus cx plus d. A, B, C, and D can be any numbers that you want. If you start changing them, you'll change the characteristics of the graph. The only restriction is that A can't be 0. So A, B, C, D are real numbers. But you don't want A 0 because if A is 0, 0 times x cubed is gone. Now you just turned your cubic into a quadratic. So A can't be 0. But other than that, A, B, C, and D can be any real numbers you want. Okay, I've already shown you some of the different types. I just did that on the other page. It can cross 3 times, 2 times, 1 time. Other than what I showed you, it can curve the other way. So instead of going down on the left and up on the right, it could go like that. It's kind of like a mirror image. Up on the left, down on the right. That's still a cubic. Okay? Same thing here. We could do a mirror image of one of those. Okay, I already had them drawn, but just showing you. Okay, so basically all cubic functions are going to look something like that. All of them. Okay, so let's graph that, and I just want to know how many solutions it has. Now, I didn't write what kinds of solutions, so we always assume what kind of solutions if it doesn't say. Yeah. I'm thinking of like a type of number, like whole number. Chris?
All real solutions.
Reals, yep. Don't worry about imaginaries yet. So, we're just focusing on reals. So, x cubed minus. You gotta remember to hit that arrow sign. If you don't, you'll type everything up in the exponent. Has anyone done that yet? You just type it all in the exponent and then you look at it after and it's all in the wrong spot. I'll probably do that at some point. Plus 6x minus 1. So the question is not to actually find any solutions, just how many. How many solutions does it look like we have? Well, actually, 3. Okay, so we have 3 solutions. How many x-intercepts do I have in that equation? Okay. 3. How many roots do I have in that equation? 3. How many zeros do I have in that equation? 3. I'm just showing you 4 different ways I can ask the same question. Okay. All the same thing. And then I think the next question, I'm going to skip this one, is find the middle root. You just do second calc 0. It's somewhere between 1 and 2. Looks like it's about 1.5. But we've already practiced that. All right, so last thing we'll look at, part of section 2.2. And actually the last question in 2.2 we've already done, so it's not really that much more. So finding a complete graph. Yeah? Yeah, just sign out for me. So finding a complete graph, what does that mean on the calculator again? If they ask you to find a complete graph, like how do you know what you're looking at as a complete graph? You can, yeah.
You can see all the importance.
Yeah, you can see all the important stuff. So for like a cubic, you can see the twists and turns. For a line, there's no twists and turns, but if you can see the x and the y-intercept, that's good. So basically, can you see the important stuff? So a lot of times when we solve an equation, we're either going to, or solve a word problem, we're going to do one of 2 things. We're going to make an algebraic representation of the word problem, which means make an equation, or we're going to do something graphical. So those are the 2 main approaches to solving any type of word problem. Either use algebra after you create an equation, or use a graphing calculator after you create the equation. Right. So the problem we're going to look at, we'll set it up as an equation. I think I'm probably going to solve it graphically because it's going to be an Algebra 1 level equation, and I'm going to assume most people would be able to solve it using algebra. Graphing calculator is a little bit newer. All right, so in this problem, Bill has $20,000 to invest. Okay, he's going to invest money in 2 different investments. One portion he's going to invest at 6.75%. The other one he's going to invest at 8.6%. And both of these investments pay in what's called simple interest. So the first thing I have to give you is what is the formula for simple interest. Okay. It has a T, an R, an I, and a P. Anyone know what the formula is? It starts out I equals. Yep.
I was like,
You don't have to tell me what things are called if you're not sure, but if you just know like what you do with the letters.
oh, I'm not sure what the letters. I knew what they were called.
Okay, yeah, what are they called?
So it's like time,
Yep.
interest. The P is the amount you start with. Right?
Yep, that's called your principal.
Principal, and remember what R is.
R is your rate of return, or the rate of what your interest rate is. So the formula is I equals PRT. Principal times rate times time. Now, most investments don't work this way. Certainly stocks don't. Stocks don't guarantee you any. There is no guarantee with stocks. You could put in $1,000 today, and then tomorrow it's worth $400. So you just lost $600. And savings accounts, most savings accounts pay you interest, but they don't do it in simple interest. They do what's called compound interest. That's a little more complicated, so we're just sticking with the simple formula. right, so Bill's got $20,000 to invest. He's going to put it in two different investments. We're going to let X be the amount of money that he invests at 6.75%. So Bill is going to invest X dollars at 6.75%. And what I want to do is write an equation to show how much interest he earns in 1 year. Now, how many investments is Bill being part of here? How many investments does he have? Yep. Two. So he's earning interest from two different investments. So what we're going to have to do is figure out how much interest he makes at the 6.75% investment, and then how much interest he makes in the other one, and then total them up. Okay? Because his interest is a sum of the two investments. Okay, so let's start with 6.75%. Okay, how much money is Bill investing at 6.75%? Vote, right?
Wait, what? 20,000? That's the only number that I saw. 20,000.
Well, he has 20,000 to invest, but how much of that is going towards the 6.75 investment?
6.75 of that. Wait, what? You just X. I don't know. I don't know what's going on.
So he's investing X dollars at 6.75.
Oh.
So the problem tells you, assume that Bill invests X dollars at 6.75.
Oh, so it's just
We don't know what X is,
Oh.
but that's how it's represented. So that's his principal. Now, what's the rate of this investment? Yep. 6.75 what? So what is six? She said 6.75. But what does it say the rate has to be in that formula? Oh,
Decimal.
yeah, it's got to be a decimal. Decimal. So not a percent. So how do we change 6.75% to a decimal? Chris?
Divided by 100.
Yep. And if you divide that by 100, what do you get?
0.67.
0.0675. Let's move it 2 places to the left. All right, so we got our principal, we got our interest. Last thing I need in the formula, time. How much time is going by? Yep.
1 year.
1 year. So I don't even really need it. So the amount of interest that is earned is 0.0675x. We usually put the coefficient before the variable. If you want to leave it after, that's okay. There's your first amount of interest. Now let's do the interest at 8.6%. Okay, so first thing is the principal. If Bill had $20,000 to invest, how much is he investing at 8.6%?
What would be the 20,000 minus X?
Yep, 20,000 minus X. So subtract what he already invested in the other one from the total he has. The rate, 0.086. And the time, well, it's just 1 year. So this one we can clean up a little bit more because I can distribute the 0.086 since it's on the outside. So let's do that. So 20,000 times 0.086 gives me 1720 minus 0.086x. So we have how much interest from the first investment, how much from the second investment. How would we get the total? Yeah?
Add them together.
Add them up. So I'm just going to combine like terms as I go. So I've got 0.0675 plus negative 0.086. I think I messed that up. So 0.0675. I'm just going to look at it as minus 0.086. So when you combine the x's, you get negative 0.0185 x, and then the 1720, there's nothing to combine it with. Okay, so there's a formula to calculate the total interest based on how many dollars are invested at 6.75%. So you tell me he invests $1,000, I'll tell you how much interest just by plugging in 1,000 to that formula. Yeah?
Why is he getting a negative interest?
Well, what's going to end up happening is the more money that's invested at the lower interest rate, the less interest he's going to make. So there has to be something to account for the fact that this investment doesn't pay as well as this investment. So when we graph it, you're going to see basically that if he put all his money in the other investment and he put $0 in the lower one, he would make $1,720. That's the most interest he could make. As he starts to put more and more money in the lower paying investment, he starts losing interest, and that's why that's a negative right there. Yeah. So you basically see it as a line like this. Interest is going to keep going down the more money you put in the lousy investment. It's not lousy, but it pays lower. So remember when you graph something, and we've done this before, use common sense. Negative money doesn't make sense a lot of times. Negative time, negative distance. So there's a difference between finding a complete graph for this equation and then finding a complete graph only using the values that make sense. Okay. For example, I wouldn't set your x min any lower than 0. Doesn't make sense to invest negative money. Okay. I wouldn't set your y min any lower than 0. Okay. Negative interest doesn't make sense either. So that's what I'm trying to get at right here. All right. So let's say that Bill earned $1,509.10 in interest. How much money did he put in each investment? Okay, so let's just copy over the equation. T sub I, I'm just having that represent total interest. So total interest was negative 0.0185x. Okay, and now they're telling us he earned a total of $1,509.10. So Jarek, where would that $1,509 get plugged in?
The total interest.
Total interest. So fill that in. Right there. It's $1,509.10 equals, and I'm going to put the other side in y equals mx plus b form. Actually, I already did. Never mind. So I'm just going to copy it over just like that. So that equation on the right-hand side is basically a line. Okay, so what I'm going to do is I'm going to do this one a little different. Let's graph what's on the left in y1. So we're going to put a horizontal line at 1,509. 1,509.10. I'm going to graph what's on the right in y2. Negative 0.0185x plus 1720. And now I know I have to adjust my window because my y-intercept is 1720. So let's set our y-max a little higher. Let's do 1800. So I said y-max 1800. There's no risk in this investment, so he's never going to lose money. It's simple interest doesn't work that way. So negative money doesn't make sense. negative investment. Bill doesn't have negative money to invest. That doesn't make sense. And what about x max? What's the biggest that x could be? Yeah.
The 20,000 started.
Yeah, Bill only has 20,000 to invest, so we can't look at more than 20,000. So if we hit graph, that's a mark showing our interest. And that's what happens to his interest as he invests more and more money in the investment that doesn't pay as much. So let's calculate where they cross. Now if you're like, well, why didn't I do this as a 0? I could have moved the 1509 to the other side, gotten it equal to 0, and found the answer that way. It's going to come out exactly the same. We practiced a couple with that, so we didn't do one with an intersect today, so I wanted to try that. Pick a point on the blue, pick a point on the red, and do your guess. So we get $11,400 for x. Let's go back. X is the amount of money at 6.75%. Bless you. Was it 11,400? So if Bill invested 11,400 at 6 3/4, how do I figure out how much he invested at? I think it was 8.6. Yeah. How would I get to 8.6? Yeah, Lee?
Subtract 6.75% from the total.
Yeah, just subtract if 20,000 is the total, subtract that from 20,000. So how much did he invest at 8.6? 8,600, yep. Okay, so in terms of word problems, that's definitely one I would look over again for the test tomorrow. It's a good one to look at. The last one, I think we've already done this in a homework problem. What was the best shape if you want to enclose the most area and use the least amount of fencing to do it? It was a square. Yeah. So it turned out to be 25 by 25. So we've already done that. All right, so homework tonight on page 82 and 88. We'll go over that before the test tomorrow. Okay, if you have any questions, don't forget I am here after school. And also, if you subscribe on the YouTube, I think I mentioned it a few times already, you got 5 points on the first test.